we're going to go over another theorem. It's going to be theorem, let's see, it'll be theorem 0.048, and it's going to state that if a point C is equidistant from points A and B, then C is on the perpendicular bisector of AB. And that makes sense if we draw a picture of it. If we have this segment here with A and B, some kind of perpendicular bisector here, we'll say this is L sub 1. It makes sense that this point C is on this line. If C was over here, we'd be kind of confused, and these have to be the same length. So let's move on to the proof of it. Proof. We'll say let M be the midpoint of the segment AB. If C equals M, then we can say that C is clearly on the perpendicular bisector. And we have to be careful with the word clearly. We really shouldn't be using it here, but something else would take a little bit of time to say. So we'll say, suppose C does not equal M. So C is somewhere else on the line. Let's draw another picture for where this would be. Go down a little bit. Say we have B here, A over here. M is our midpoint. And we have C an equal distance from A and B. So we'll say this length equals that length. So we'll suppose C is not equal to M. And we can say, since, M is the midpoint of AB, so we'll say that line equals that line. Anyways, since M is a midpoint, we can say that AM is perpendicular, or not perpendicular, but congruent to BM. Then, by side, 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 triangle AMC is congruent to triangle BMC. And we can say that by corresponding parts, of congruent triangles, angle AMC is congruent to angle BMC. And then we can say that since these two angles, which are angle AMC and angle BMC, are supplemental angles, Well, since those are supplemental angles, we can use the supplemental angle axiom. So by the supplemental angle axiom, measure of angle AMC plus measure of angle BMC equals 180 degrees. I'm going to say that therefore angle AMC equals, or the measure of angle AMC equals the measure of angle BMC, which equals 90 degrees. And by definition of right angles, they are right angles. I think I forgot to say it in that video. A lot of times we'll abbreviate right angle as just RT. Then the line CM is the perpendicular bisector of AB. And C is on the perpendicular bisector of AB. And that's the end of our proof.